In this video, we are going to look at the mechanism of action of insulin. That is how, or let's say, mechanism of insulin secretion from beta pancreatic cells. That is how the insulin is produced and secreted from the pancreas of the human system. Now, the pancreas is a gland which is just positioned below the stomach. The pancreas has two main cells. It has the alpha cells and the beta cells. The alpha cells secrete a hormone called glucagon, produced in response to a low glucose concentration, and you have the insulin produced from the beta pancreatic cells, which is in response to a high glucose concentration. So normally when you are in a fed state, the body has to produce insulin, and this insulin is normally used in the care of type 1 and type 2 diabetes. Now the insulin helps in transport of the blood glucose into the cell so that it can be metabolized for use. Now let's look at how this insulin is produced by the cell. By the beta pancreatic cells. Normally, patients with type 2 diabetes who are having impaired insulin secretion, the drugs which have been administered to them, such as the sulfonylureas drugs, mimics the natural way of insulin secretion from the beta pancreatic cells to secrete insulin so that it can be used for use. Now, let's see how insulin is produced, or let's say secreted from the beta pancreatic cells and help the transport of the glucose from the blood to the cells for energy production. Now let's assume you are in a first state. You eat, let's say, how your food, and the food runs through your alimentary canal. Then the food is absorbed from the small intestines and into the bloodstream. Now what happens? This here is the beta pancreatic cells that has several components. It has what we call an ATP dependent or ATP sensitive potassium channel that allows an influx of, or say, efflux of potassium from the beta pancreatic cells to the outside. It has also a calcium gated channel which allows calcium to move out of the cells into the cell. Now these two channels are what aid in the transport, or let's say secretion, of the insulin from the beta pancreatic cells to the blood. Let's say you are in the first state. When you are in the first state, glucose which is in the blood find themselves in the beta pancreatic cells for energy production. So shown here is glucose that enters the pancreatic cells for the glucose transport to. That is shown here. This transporter is just specific for pancreatic cells, and they allow glucose to enter the cells when we have an elevated glucose level in the blood. Now, as the glucose enters the cells, of course, we have an enzyme called glucokinase that phosphorylates the glucose to prevent its efflux from the cell. It undergoes through glycolysis, the Krebs cycle, and further electron transport chain to produce ATP. Now, these two reactions, which is the main reaction of the respiratory chain, helps in production of high amount of ATP. So when we have high ATP produced, the ratio of ATP-ADP ratio becomes elevated. Now the channel here called the elevated, or the ATP-dependent potassium channel, is sensitive to potassium. It allows potassium to flow out of the beta pancreatic cells to the extracellular fluid. For that matter, at any point in time, we expect to get more negative charges inside the cell and more positive charges outside the cell. This condition is called the resting membrane potential of the cell. Now, as potassium moves out of the cell like that, we maintain the resting membrane potential of the cell. When there is a blockage of this channel, now this condition becomes distorted. That is what we call what? A damage, or let's say a disruption to the resting membrane potential of the cell, called depolarization. Now this channel is called an ATP dependent because when there is high level of ATP, the ATP produced blocks the channel and prevents the transport of the potassium from the cell to the outside. Now in the case of high glucose concentration, glucose enters the transporter and gets converted to ATP through the respiratory chain, that is glycolysis, the Krebs cycle, and also the electron transport chain. Now the ATP produced here binds to this receptor, or say binds to the transporter, and causes the closure of the transporter, or let's say this channel. When the potassium channel closes, there is going to be no efflux of potassium from the inside of the cell to the outside. This is going to cause a damage to the resting membrane potential of the cell. For that matter, there is going to be an accumulated potassium ions in here, which is going to damage the negative charges to the positive charges. Then this is going to cause a damage, or a depolarization. Now the depolarization here is when there's a damage to the resting memory potential. That's when the negative charges inside the cell get distorted. Whenever there's depolarization, what happens next is there's going to be an opening of a calcium gated channel, which is a voltage gated potassium channel. Whenever this channel opens, calcium flows out of the cell to the inside. The flow in here is to open another channel so that the cell can kind of remain, also regain its potential. Now we have blocked this channel because of a high level of ATP, and that we have disrupted the resting memory potential of the cell. For that matter, the calcium will flow outside to the inside. Now when it flows outside, the calcium here says activate an insulin gene expression via this protein. The protein is called a calcium responsive element binding protein. When the calcium activates the gene, it is going to express the gene that helps in the synthesis of insulin. So with calcium influxing, it's going to synthesize or help in the synthesis of insulin in the cell. When we produce more insulin in the cells, we are now going to secrete, or let's say package these insulins in the vesicles, and they get released through exocytosis. So upon the blockage of the potassium channel, we are going to have a depolarization, then a calcium influx. Then when the calcium flux in, we are going to produce more insulin through transcription. This transcription is just because the gene for the insulin production is going to be expressed, and the gene is called a CREB. When this gene is expressed, you are going to synthesize more insulin, and the insulin synthesized here is going to be packaged in the vesicles. When they have been packed in the vesicles, it will now move out of the pancreatic cell beta cells through exocytosis to the blood. So that's how how insulin is released. Very simple. When there is high glucose level in the blood, glucose enters the cell, the beta pancreatic cells, through the glucose transport tube. Then in the beta pancreatic cells, we are going to convert the glucose into ATP through glycolysis and oxidative phosphorylation. Now the high level of ATP in the body is going to bind, ATP is going to bind the potassium channel to cause its blockage. When the channel blocks, we are going to cause a depolarization, which is just a damage to the resting membrane potential of the cell. When there is a damage to this the resting membrane potential of the cell, we are going to have a calcium influx. Calcium moves out of the cell to the inside. This is because we have closed the channels. The body has to open different channels to regain its membrane potential. In doing so, the calcium comes in to activate the insulin gene, which is the calcium responsive element binding protein. When this gene is activated, we are going to have more calcium being synthesized and more insulin being synthesized. And when insulin is being synthesized, it's going to be packaged in a vesicle, then get secreted. So the vesicle here is called the granules. That after transcription of the insulin, we are going to have it secreted in the granules and get excreted or say released through exocytosis. Now, aside the action of insulin secretion by the calcium, whenever calcium is being produced, once the calcium is influxed in the cell, it is going to activate a cyclic AMP, and this cyclic AMP is going to activate what they call an incretin. An incretin is called a glucagon-like receptor that inhibits or prevents the secretion of glucagon. So, in the case of high insulin concentration, or let's say high glucose concentration, the body helps in insulin production as well as helps in the secretion of insulin, incretin, and this incretin inhibits glucagon, so that it will be inhibited, because when we have high glucose in the blood, there is a need for us to secrete insulin and not glucagon. So that's how basically insulin is secreted in the cells, or let's say in the beta pancreatic cells. Thanks for watching. Don't forget to like and for watching so you can receive every bit of updates from this channel.